Hi, I'm Ms. Cho, and in this video, we'll solve polynomial inequalities algebraically. Let's take a look at what we mean by inequalities. When I say that I have some polynomial p of x is greater than 2, what it means that is if I'm looking at a graph and I draw a line at y equals 2, it's all the points of the polynomial that are above this line. Now, if I was just solving an equation, I would be looking for these points of intersection, these x values. But since I'm looking at an inequality, it's all parts of the graph that are above this line. And my answer will be an interval with all of these x values. I can write interval solutions three different ways. One is inequality notation. That's where I have less than or greater than signs. And in this case, it would be x is less than a, b is less than x is less than c, or x is greater than d. In set builder notation, it's basically inequality notation, except with an extra brace and a line signifying such that. So this is the set of x's such that, and then everything I have in my inequalities above, I just recopy. So x is less than a, or b is less than x is less than c, or x is less than d. Remember that when you have a compound inequality, your symbols need to face the same way, both less than. And the third is interval notation. This is where I have two numbers separated by a comma and then a parentheses or a bracket situation, depending on if it's open or closed. So in this case, it's negative infinity to a, or b to c, or d to positive infinity. Let's take a look at an example. In this example, we're asked to solve the inequality 3x cubed plus 4x squared plus x is greater than 2x cubed plus 5x squared plus 13x. When we solve an inequality algebraically, it's similar to solving an equation. So we're going to set our inequality equal to 0. Then we're going to find our zeros, and then we're going to do two extra steps. We'll sketch the graph to determine positive or negative intervals, and then we'll write out our final solution as intervals. Let's start with setting our inequality equal to 0. To do that, I'm going to look at my highest degree exponent, and I see that I have a 3x cubed and a 2x cubed. I want my leading coefficient to be positive, so I'm going to subtract the 2x squared, bringing it from the right side to the left. This is a personal preference, but I find it less confusing to deal with positive leading coefficients. That means I'm going to set my right side equal to 0. So I'm going to subtract the 5x squared and then subtract the 13x. And this leaves me with 0 on the right side and an x cubed minus an x squared minus 12x on the left. Once I've set my inequality equal to 0, I can find them. You can do this by looking at a graph, but since we're doing this algebraically, I'm going to try to factor. So we have a couple different factoring options. So looking for GCF, polynomial identity, or factoring by grouping. In this case, I see a GCF. Since every term has an x, I can factor out the x. So that leaves me with x squared minus x minus 12. And I'm going to set this equal to 0 because I'm solving for zeros. And I can see that my trinomial is a quadratic, so I can either try to factor that more, use the quadratic formula, or complete the square. I see that this is factorable because I can think of two numbers that multiply to negative 12 and add up to negative 1. And so that's positive 3 and negative 4. And so once I have my equation in factored form, I can use the zero product property, set all my factors equal to 0. So x is equal to 0. If x plus 3 is equal to 0, then my x is equal to negative 3. If x minus 4 is equal to 0, then x is equal to 4. Once I have all my zeros, I can sketch the graph to determine my positive or negative intervals. I'm going to line all my zeros up in order, so from negative 3, 0, and 4. And then I'm going to use what I know about end behavior, using my degree and leading coefficient, and also the multiplicity of my zeros to figure out what this graph looks like. I see that my degree, my highest exponent is 3, which is odd. So that means my ends are going to go opposite ways. And because my leading coefficient is positive, I know that the right will go up and the left will go down. Also, as I look at my factors, I have one copy of each. That means my multiplicity is odd and my graph will cross through the x-axis at each of those points. Since I know I'll cross at -3, I'll cross at 4, and I'll cross at 0, I know that my graph looks something like this. Once I have this graph, then I can decide what intervals I'm looking for. From my polynomial, that I can see that I'm looking for parts of the graph greater than 0. So that's above the x-axis here and here. And so when I look at what x values that means, it means that I am looking for an x that is between -3 and 0, or an x that is greater than 4. Or in interval notation, this is -3, 0, or 4, infinity. Let's check the work on a graph. I've graphed the boxed polynomial that's greater than 0. And as you can see, the parts of the graph that are above the x-axis are between the -3 and 0, and also greater than 4. Let's summarize. When we solve polynomial inequalities, our solutions are intervals. We can write them in 3 different ways: inequality, set builder, or interval notation. To solve your inequality, you first set it equal to 0, then you find the zeros using factoring or by looking at a graph. You sketch the graph to determine positive or negative intervals, and then you write out your intervals in any of the notations given above.